Welcome to Nethopper's webinar. My name is Claire Cobden. I'm the head of marketing. I'm going to be your host today, and very excited that you're here. So today we're going to talk about the best way to manage, operate, and connect Kubernetes containers between clouds. So if we go to the next slides, I have a few housekeeping items to tell you. So first of all, the webinar is being recorded. All audience participants are on mute for the duration of the event. And comments and questions can be submitted by using the chat window. We will answer all of the questions at the end of the session. And finally, we will make this recording available to you as soon as we're done with the webinar within 24 hours. And with that, I would like to introduce Chris Mumford. Chris Mumford is the CEO and founder of Nethopper in the next slide. And Chris, would you mind telling us a little bit about your background very quickly, please?
Sure. Thanks, Claire. Good morning, everyone. Thanks for joining our webinar today. I've been at 5 different technology startups in my career, always in networking and data center. Several of those have been fortunate enough to be acquired, and I've then had the opportunity to work with some Fortune 100 companies. I first started in engineering and went into solution architecture and then eventually sales. So I got to see a lot of different perspectives on what Fortune 100 companies are doing, particularly as they've struggled with going to the cloud over the last decade, and more recently in adopting Kubernetes for their applications. Some of those companies have really, as I've gone through that journey, I saw how difficult it was, how many people it took, and I started Nethopper to basically make it easier for enterprises to operate their applications in multiple clouds.
Excellent. Thank you, Chris. And we also are going to have Dan Donahue, who's the head of our solutions architect team. And then we'll drive the Q&A session in the end with Chris. Welcome, Dan. Great. So with that, we have a full agenda today, and we have a lot of content to cover in a very short period of time. So we're going to go ahead. Let me ask you a question, Chris, as it relates to the topic of the webinar. So the topic is the best way to get to manage, operate, and connect Kubernetes containers between clouds. So that's exactly it. I just want to make sure that why is this so important for DevOps teams? So please go ahead.
Sure. Why should DevOps care? DevOps teams are the teams that are responsible for developing and operating applications. Of course, applications are the things that allow companies to compete and excel. Without good applications, today's companies in the world of digital transformation don't do well. So there's a lot of responsibility on DevOps shoulders for producing really good applications and being able to add features to them really quickly. And the DevOps team should care about Nethopper because they're struggling to keep up. They're struggling to create great apps. There's millions of them globally, to create great apps and update them to continue to be better than their competitors. And there's some of these there's actually 3 struggles that most DevOps are going through right now. One, which is really clear and apparent, is their transition from monolithic applications to microservices based applications. And the DevOps guys know this all too well, where they're breaking their applications up into small little pieces and managing them. And they have a lot to worry about in there. But there are 2 other struggles that their corporations are going through, which may or may not be directly visible to them. One is the transition from bare metal and virtual machines to cloud native containers or Kubernetes. And this is a big learning curve for a lot of corporations to go through this transition. And the other is in the infrastructure teams. They're transitioning from what used to be private data centers to cloud data centers, and actually a proliferation of cloud data centers, known as multi-cloud, or sometimes it's called hybrid cloud or edge cloud. And this transition, all of these three things combine to make the life of DevOps very difficult. And you basically don't get a lot of sleep. So we're going to talk about those three struggles today and how you can make them better. So, for example, don't just take our word for it that these are three major trends happening. You can take Priyanka's word for it at the Cloud Native Compute Foundation. This is basically for application developers developing applications in the cloud. And she says Kubernetes adoption among the ever-expanding cloud native community is approaching 100%. There's a mantra, never say never. And I think the corollary to that is never say 100%. And she didn't. She said approaching 100%. But what this means, and I wholeheartedly agree with it, is that Kubernetes has won the container orchestration war. There were lots of ways to do this, and Kubernetes is, if you go into the DevOps teams or IT teams in most enterprises, Kubernetes is the future of how they will deploy applications. I actually think that some people, when they went to the cloud, their first journey was to go to the cloud was to say, I want to stop buying computers and I want to start renting them in the cloud. So I'm going to the public cloud. The second journey to the cloud is that people have realized that they don't actually want computers in the cloud. That was a means to an end. What they actually want is to run their software in the cloud. And the best way to do that is not to rent a computer in the cloud. The best way to do that is to containerize your software and put it in a Kubernetes cluster in the cloud. And so Kubernetes is winning the war and everybody's embracing it. A second data point is a study that just came out from Digital Reality on the Global Data Insights Survey. And they surveyed about 7,000 people across hundreds of companies in 9 industries. Companies that are sizable companies, $100 million plus in revenue per year. And they asked them, how many clouds do you have? How many clouds do you operate your infrastructure in, both private and public? And you can see a graph here, and I'll explain it in a little bit. But one of the summary takeaways is that the wealthiest companies, the ones that have the largest revenues, 62% of those operate in over 50 cloud locations, both public and private combined. And you can see that in the chart down here. If you follow the light blue line, you can see that of these companies with $1 billion plus in revenue, less than 1% of them have between 1 and 10 clouds, which means almost all large companies have over 10 clouds. And think about that for a second. These are the same companies that just a few years ago struggled with going to the cloud for the first time. But you're telling me that almost all of them have more than 10 clouds? And if you look at how many of those large companies have between 11 and 20 clouds, it's only 3% of them. 35% of them have between 20 to 50 clouds, and 62% of them have more than 50 clouds. If there was a category here that said 50 to 100 clouds, or 100 to 200 clouds, or 200 plus clouds, there'd still be a high percentage of large companies that have more than 100 clouds. So the number of clouds public clouds went from 1 to 50 very quickly in large enterprises, and it shows no sign of slowing down. The dinosaurs are off the island. Once you allow your IT teams to swipe a credit card and build a cloud instance, the number of cloud instances is going to continue to rise.
Powerful stats, Chris. It's an undeniable trend, but let's get to the bottom of this. We know this is not a new topic per se. So how is this multi-cluster, multi-cloud impacting DevOps day-to-day activities? That is, based on your experience, how is DevOps handling it today?
Sure. So they're struggling with these 3 different problems. And there's 2 particular large problems. They're the ones that Nethopper's trying to solve. And at a high level, I want to explain the problem in a little bit more detail. So as we just discussed, IT has a growing number of clouds. It's no longer 1 or a small number. It's 50 plus, or 100 or 200 or 400. And these can be private clouds. They can be their core public clouds, regional public clouds, edge clouds, branches. But the number is growing. And now when we think about what a DevOps person must do to both develop and operate an application, particularly operate an application, is we know that these applications are breaking apart from monolithic apps to microservices-based apps. So now there are a lot of small little moving parts to an application, which can be developed in an agile way and increase features in their corner of the application. And of course, all of these little parts need to communicate with each other through little micro APIs or microservices. That's where the name comes from. This is what the application looks like, and it becomes the operations team of the DevOps partnership to do a couple things. One is they need to place those microservices in the clouds. And if you have 400 clouds, the question becomes, or hundreds of clouds, or even 10 clouds, the question becomes, where do I place these containers? There's a many-to-one relationship between where my containers are, between where my containers must be placed and in which clouds. So that's the number one problem that we try to solve, which is how to get the containers into the right clouds. But if you notice, there's another problem that's occurred, which all of the connections between the containers also need to be moved to the clouds. And anybody who's ever tried to connect two secure clouds together and enable a white line, enable a communication between clouds, knows the difficulty of connecting, opening up secure firewall ports and doing the networking things that are necessary to allow any two applications to talk to each other. Well, if you have hundreds of clouds and hundreds of microservices, you potentially have tens of thousands of communication lines between clouds. And that's a problem that Nethopper solves as well. We help make it very easy for these containers, no matter where they're put, to adapt the communication between those containers to allow the application to still run and for these microservices APIs to still communicate securely. So one of the ways that, before we get into what Nethopper does, there are existing methods for solving the problem. And these existing methods are complex. So we'll talk about the current way, or what is soon to become the old way of solving this problem. Let's take an example where you have just 3 clouds, not 100. And you have an application with just 2 microservices, not 100. You have a microservices called a front end and a microservice called a back end. The front end is in one cloud and the back end is in 2 other clouds. The old way of solving this problem is you need to have terminals available in each one of these clouds, and you actually tell via command line, you tell this cloud, I want a front end. You tell this cloud, I want a back end. You tell this cloud, I want a back end. So there's a lot of manual operations to go to each cloud and say what you want in that cloud. And that's generally known as operations. It can be automated through something called GitOps, and you may have a GitOps tool that you're using to do this. The next thing that needs to happen is, if any 2 containers are going to communicate with each other, it's generally recommended to have a service mesh. One of the most popular service meshes in the world today is Istio. It's an open source project that comes from Google. And if you ask anybody about it, it's very likely that one of their first comments is going to be how complex it is. I hear this every single day. It's made even more complex when you use a sidecar approach, which was recommended for security purposes. And that's generally deployed through a project called Envoy. So now you have to have service meshes, one in each of your 3 clouds. If you had 100 clouds, you'd need to have service meshes in 100 of your clouds. And of course, to allow communication from front end to back end, to allow this service communication, any communication into a Kubernetes cluster requires something called an ingress or an API gateway. So you need one of those in each cloud as well. And then to actually control the cloud networking operations, like the IP gateways and the firewalls and the load balancing, it would be very tedious to do that by hand. So most people have a team of people that automate that network infrastructure, either through a multi-cloud networking tool or through infrastructure as code using something like Terraform or Ansible. And so if you take these 6 or 7 tools and 6 or 7 dashboards, that's how you're supposed to get containers in the right clouds and communicate those containers across clouds. It generally involves several teams, dozens, if not hundreds of people, to do this for a large application. And this is what is so complex and so costly. And it actually hurts the ability for the company to produce applications very quickly and to upgrade those applications very quickly. So that's where Nethopper comes in. We have a new way of doing this, which requires I should say, as I built this last slide here, this is a huge integration effort, and most of it is open source. So you'll struggle, a large enterprise will struggle to get support for these tools because they are not offered by companies, they're open source projects. And they'll have to integrate these projects together, and then that'll be an ongoing support effort for them. So Nethopper has a new way of doing this, which solves many of these problems. We also use open source in our project, but we have a single product that attempts to do does all of what those other collection of 6 or 7 products does. And we offer it as a service, a solution as a service, which is a very popular method of helping enterprises with solutions today. It starts by going to nethopper.io and signing up for a service. You'll see sign into console in the upper right-hand corner. And with an email and a password, you can very quickly start off building your multi-cloud application network. And what it allows you to do is place front ends in the clouds that you want them, place back ends in the cloud that you want them, and communicate securely between them. And we manage all of the security implications like keys and encryption and decryption across our multi-cloud network. I actually want to, this purpose of this webinar is not a demo, but I'm going to give you a very quick one, which is going to distribute this application and connect it across clouds with about 6 or 7 clicks. It's not an exhaustive demo, but if you'd like an exhaustive demo, you can certainly contact us over here at Nethopper, or you can go try the free tier at nethopper.io and you can do what I'm about to do yourself. So let me lower the presentation for a second, and I'm going to bring up our Nethopper console. Actually, 2 different pictures of our Nethopper console. One page of our SaaS product is a dashboard. And you can see in this dashboard, I have very little things. I have no clouds attached right now, so I'm not aware of any clouds in my multi-cloud operation, and I have no objects. So I have no containers in any of my clouds. And here is the kind of the home page of Nethopper, or the application networks page. And I'll talk about this in a second. The way, as I said before, many people are manipulating their clouds right now is through a terminal. So if you have 100 clouds, you likely have 100 terminals open, and your operations guys will be doing this right now. And if they want to do anything in Kubernetes, there's a great tool called kubectl. And you can, for example, get all of your resources, list them out, list all of your resources in the cloud. And you can see right now I have one single resource in this cloud, which is my AWS cloud, you can see here. And it's just the Kubernetes API. And I also have one single resource in my private cloud, which is the Kubernetes API. This is what a blank Kubernetes cluster looks like. So I want to show you that we're going from an absolutely blank, 2 blank clouds, to 2 clouds with to an application distributed across these clouds and connected. So I'll show you that in 6 or 7 clicks. So fundamental to Nethopper is an application network, and I'm going to attach a couple of clouds to my application network. The clouds I'm going to attach my AWS cloud and also my private cloud. And I'm going to attach those together in a fault-tolerant way to something called a US hub. And you can have multiple hubs. And I'm going to attach them, and you can see once I attach them, now I have 2 clouds attached, and these attachments aren't fully up, they're in progress. Now, rather than having you download Nethopper software and figure out how to integrate into your environment, we have a really easy, these 7 clicks that I'm talking about, way of installing Nethopper in your clouds. So say, for example, I want to install Nethopper in the private cloud. I simply get the install instructions. I copy them to my clipboard. I go over to my private network, and I paste those instructions into my private network. And what this does right now is it goes out and it gets all of the necessary Nethopper objects to install a Nethopper agents in your cloud and starts installing them. And you can see that this private cloud is going through the install process. I'll do the same thing for my AWS cloud. I'll copy the instructions to install my application in the AWS cloud. I'll paste it in here. And you can see that that router will go through this, that Nethopper agent will go through the same process. So you can see as these things are installing, you can see that my number of clouds attached continues to stay at 2. One is now up, the other is in progress. In a few seconds, it will also go up. And you can see over here in the object screen, I've also created 4 objects. These are my front-end service, my back-end service, and the deployment, and the service connectivity between them. So now you can see I've distributed 6 of these objects across 2 clouds and connected them, and all of the status is up and green and connected. So it can be very complex, and you could use 7 tools to deploy such an application, but here we've used 6 clicks through a Nethopper tool to install and connect that application across 2 different clouds, private and public. Again, there's a lot going on behind the scenes here, but it can be very simple, an order of magnitude simpler to install applications with Nethopper than the status quo business as usual way of installing applications, operating applications today. So back to the presentation, we just built this application across multiple of our clouds. Actually, we only did between the top 2 clouds here, not the second private cloud. It was super simple to do. As you can see, it was just a web page, and we had to make a few copy-paste clicks. It's one dashboard where you can see this application running across multiple clouds in a single pane of glass. There was no code that you had to write, develop, or support. It's just point and click. It's super secure. We'll talk about security a little bit later in the webinar, but all of the placement of these containers and communication of these containers is secure, and the communication is encrypting your data in flight. It can be very cost effective because it doesn't take hundreds of people to use a simple tool like Nethopper. So you can reduce both your operating expenses for your staffing, and also you could probably reduce your cloud resources as well if you get more control over what's operating in your clouds. And it's fully supported. If anything goes wrong here, you're not left asking an open source community to please fix the problem. You have a company behind it. You have Nethopper that fully supports this product, and they can fix any problems you have. We can fix any problems you have. So just by way of comparison, the old way, which I explained on a previous slide, has lots of different moving pieces. You have infrastructure as code, GitOps, service meshes, API ingress gateways, firewalls, load balancers, and just to get a few containers deployed in a few clouds and a little bit of communication, you have a lot of tools that need to be configured, operated, monitored, and teams of people to get all of this up and running. However, the new way, an easier way, is to just sign up for Nethopper, nethopper.io, and you can very quickly install a single tool in each of your clouds and have a wizard that takes you through this install process. And then we monitor this infrastructure for you. We send you alerts and alarms via email or Slack when you have problems. So it's much easier to both turn up on day 1 and operate that infrastructure on day 2 forward. So all that to say that we make operating applications in multiple clouds easier, more secure, and robust. We'd love the opportunity to talk to you through the business case of doing this and put some numbers to these behind these numbers. But it can be about 1/10 the effort. So what you're spending on cloud operations today to operate your apps can be dramatically reduced by reducing the amount of effort you go into operating your apps. You can reduce the cost of not only your staff, but also of your cloud infrastructure by up to 1/3. And a large percentage of security breaches in applications today have to do with not protecting your data in flight, about 2/3 of them. So you can get you can increase the security of your applications by about 3x by making sure, guaranteeing that all of your application communication is encrypted. So we're the leader in what we call this application networking, multi-cloud application networking. We're the leader in this marketplace. We enable application operators to view, distribute, and securely connect apps seamlessly across multiple clouds, clusters, instances, and even different cloud providers. Nethopper is based on mature open source scupper.io. You can go to scupper.io to read more about it. And before that, several years of development with Apache Cupid Router to be able to handle the cloud communications, securely handle cloud communications between containers. To date, we're fortunate to have over 200 customers that have come and registered for our service and are using the Nethopper SaaS. It was launched just back in last May, about a year ago. So those 200 customers have happened in the last year. We have several engagements with large enterprise app development and operations teams, but we do have a few beta spots left over. So if you would like to have a targeted engagement with Nethopper and not just come and sign up free for our SaaS and not talk to anyone, you can do that. But if you'd like to have an actual engagement with our solution architecture team and our solution engineers, we would love to do that. So please contact either me or info@nethopper.io.
Great. Thank you, Chris, for your insights, for your demo in today's webinar. So I'd like to remind everyone that you can send your question. You still can send your questions using the chat functionality. And now to handle the Q&A session with Chris, I'd like to welcome again Dan. Dan, the presentation is all yours.
And great presentation, Chris. And Marcos asked a good question. He was asking, can we assume the communication between, in the demo, the front end and the back end is using a REST API? And I'm sure you can talk about that, Chris, that we can, but could you elaborate a little bit more on that, on how the messages are actually routed and how services are exposed across the application network that allow like a container like the front end and the back end to use a REST API as if it were local to the cluster?
Sure. So good question, Marcos. So of course, the front end and the back end are created by the devs, the software writer half of the DevOps team. And the devs will have an API. They'll have an HTTP listener in, say, for example, the back end, which allows the front end communication to hit those APIs. So really, it's the back end developers that are developing the APIs and determining what the back end will communicate to the front end. But the problem with having the back end and the front end in two different clouds is there's no connectivity path. There's no actual communication path between the front end and the back end. So while the APIs are determined by the back end developers, it's Nethopper that's providing that connectivity between the front end and the back end. And let's say, for example, the back end was a database with all sorts of super private information, like customers' credit cards that the front end might want to display to the customer, or other private information. You would hope that the back end developer would authenticate anybody asking for that information, require encryption of both directions of that communication so that the credit card numbers are never in the clear. And many back-end developers will do that. However, Nethopper guarantees that that communication is encrypted, because when that communication, we connect the front end to the back end across multiple clouds, and we make sure that all that communication is encrypted. So there's no chance for anybody to do a man-in-the-middle attack or get in the clear any of that information in flight as it traverses from the front end to the back end.
Thank you, Chris. Good answer. Yeah. So in short, it's like the backend container running on a different cluster would appear on the front end cluster through the application network. So you could use a REST API directly as if you were on the same cluster. So thank you, Chris. So another question people might be wondering is, like, when Nethopper builds a multi-cloud application network, who owns the network and where is it?
Yep, that's a question we get a lot. Some people are concerned that, and there are other offerings in the marketplace that attempt to build, they're companies that actually build a network, and people deploying an application would use that network to communicate. Nethopper does not do that. We rely on you having a network, and you can use the public internet if you want, or you can build a private network between your sites or between your sites and your clouds. And it's yours. You own it. You have control over the security of it. Nethopper is simply using those network resources to build what we call an overlay network on top of your physical networks that provide connectivity between your compute centers. So in this overlay network, we have full visibility of all the services in the network and can securely connect them and create new connections across the network. But we do it all through software. You're not relying on our network and our security practices. We're simply software that you install in your Kubernetes clusters that use your network for the underlay network that provides the foundation of a multi-cloud application network.
Yeah, and because of that, just because we're like a software application installed on your network, we don't need any of your credentials or any of your secrets to connect the multi-application network. Thank you, Chris. So what about performance and latency, which is always a concern? What is it with or without the Nethopper agent?
All right. So, of course, latency is the thing that's going to make your applications quick and provide a good experience for your customers. So you want to keep your applications as high performance and low latency as possible. Latency might be the thing that's actually causing you to go to edge cloud so that you can get the compute and the data closer to your customers. So we understand latency is a big deal. And as so, we build what you saw in the demonstration, we build those Nethopper agents to be super high performance. You can actually deploy, you can decide how many of those agents you deploy. So you can scale your performance by having more communication endpoints, more Nethopper agents in your cloud. And we design them in software to be super high performant. So those Nethopper agents take a couple, if you measure it, take a couple extra 100 microseconds to traverse millions of seconds. Now, when you operate across your application across clouds, you're very likely to see, even in the best edge clouds, multiple milliseconds, maybe tens of milliseconds of latency between clouds. So Nethopper adding a few tens or hundreds of microseconds is a small fraction of additional latency. So it's really not, it will be noise in your overall latency calculation, and you won't notice in your applications that Nethopper is even there as a communication path.
Great. We have a couple more questions. This is great. So Satya asks, and I hope I said your name properly, are other protocols that are popular with microservices like gRPC supported? Or does Nethopper work at the ingress and HTTP layer?
We support gRPC, HTTP, and TCP. So multiple different protocols. So whatever your APIs are based on, we'll be able to communicate them.
Mm-hmm. Great. Marcos has another question. Those, the agent interface with the remote mesh controller like Istio and Istio advertised, this new connectivity, or is this new connectivity, or do you use a sidecar at the pod level?
So there's a debate in the community right now whether as you take some of the security, encryption, communication aspects out of the pod, out of the containers, and you move it into a security communication layer like a multi-cloud application network or like a service mesh, whether you should do so using a sidecar. And what a sidecar is for every container that might want to do communications, you would set up a sidecar and you would run your networking and security inside that sidecar. Now, the people on our side of the debate would say that sidecars are complex and they're also very resource intensive because you're effectively deploying a sidecar for every single container in your network. And that means you need more RAM and more cores for every container you deploy. And this will increase your cloud costs. Now, sidecars have a benefit in that they do increase the performance of your communication. And Nethopper does that as well. But rather than going all the way to the level of having a sidecar, we allow you to have a Nethopper agent on every computer node through a daemon set, say you would call it in Kubernetes. So you can still have the performance and low latency you want, but you don't need the complexity and resource bloat that you get through a sidecar.
Great. Thank you. Last question. I don't see any more user questions, but could you talk quickly just about how we use load balancing between clouds for load balancing and high availability?
Sure. I'm actually going to share again for a moment to talk to this in slides. You can see here that what we are really trying to do, and this is something that for any of you that experienced problems last year with AWS regions going down, the de facto way of protecting Kubernetes in the cloud was to use availability zones. Say, for example, AWS, Google, Azure, and many clouds had this concept where as long as you had your microservices, your containers running in, and your Kubernetes cluster nodes running in more than one availability zone within a region, that you are protected. Of course, there were several times in both Google and Azure last year that lost whole regions. And these were days of cloud outages. They were well publicized. It affected Netflix, it affected McDonald's, and hundreds of other apps. So many people are looking for a way to not have their cloud provider or cloud region be a single point of failure. One of the ways to do that is to use multiple cloud regions or even multiple cloud providers and put Kubernetes clusters in multiple regions. And maybe even more precisely, put, say, for example, your super mission critical containers like your backend, which is your database of information generally, or any server, any microservices that are mission critical, put them in multiple clusters. But of course, then you need a way for any container like the front end that would like to access the back end to do it in a highly available way. And the way that you do this through HTTP or gRPC communications is you do it through load balancing, where the front end will either get its information from this back end or a collection of other backends, and it does that through application load balancing. Typically, when you want to do this today, you have to program application load balancers in each cloud. But you do not need to do that with Nethopper. These Nethopper agents, through scupper.io and the Apache Cupid dispatch routers inside here, actually do the client-side load balancing. So when the front end requests service of the back end, these agents actually make a load balancing decision right here, which back end they're going to reach out to. They know the health of the different backends. They know the latency to reach each of these different backends, and they know or allow you to program the cost of reaching each of these backends. And so it'll try to reach out to the lowest cost, lowest latency backend available. So we handle all the load balancing for you, which will help increase your performance and your availability of your applications.
Thank you, Chris. Yeah, so in short, we support load balancing, which provides high availability for your mission critical clusters. Those were great questions. Thank you for submitting them. Thank you, Chris, for answering them. And pass it over to you, Claire.
Thank you, Dan. Nice job. Also, I would like to thank Chris for his presentation again and the demo. And most of all, I'd like to thank you who took the time to attend today's webinar. Thank you. This is a wrap, and I hope you enjoy it. See you next time. Ciao, ciao.
Thank you, everybody.